People, may I couldn't set up a camera here. Next week I will be setting up a camera. Today I did it in a hurry. So, people, I thought of doing the questions today, but later changed my mind in order to do some theory part today. So let's get straight back to it. Hurry. Okay, now unit 3. People, chemical calculation, one of the most important units of the chemistry syllabus. People, this unit will directly correlate with the other physical chemistry unit. This is the base rock of all the physical chemistry units. Haritha, now people, first of all, now introductory part, basic concepts we have to learn here, and then introduction to mole concept, and we learn moles and molar mass, and then later that will be the first question pattern which you will learn. And then we learn stoichiometry. Then we are going to like introduce the mass and the moles concept into stoichiometry. And then we are learning about reactions and then limiting reagents. You can see limiting reagents are coming up. And then another question pattern will be coming up. And then finally, the please mute yourself, everyone. I forgot to disable that option. Right? Then deriving the molecular formula part from the empirical formula, that's also a question pattern. Sometimes you might get an MCQ from it, very rarely. Then question number, sorry, may unit conversions also we will be doing in the chemical calculation class. Because unit conversions, this will be important for all of the subjects, especially chemistry, how to convert mole per cubic decimeter to like mole per cubic meter. How is it like to convert in between different units? There are many different, like milligram per cubic decimeter to milligram per cubic centimeter. Okay, there are many unit conversions which you need to learn in chemistry. So everything you're going to learn here. And then next one, mixtures. Now we are going to learn, after that you can learn mixtures, fractions, molality, and then density. This third one is not important, that is out of syllabus. Then people, we are going to go for another question pattern, question halt number 4. And then finally, primary, secondary standards. This a lot of you don't know about this. This is like the chemistry lab side we are going to look at under chemical calculation. Lab big actually what are you going to do, like how to prepare a solution, like how to wash. Even we are going to learn. Are the laboratory equipments and stuff, pipette and the important information regarding it you're going to learn. Normal glassware cleaning procedure we are going to learn. So everything is included here. And then finally we move into titrations and then followed by the redox reaction methods. Other redox reactions and oxidation and reduction by the same compound. And then final the revised exercises, and then with that we are done. Okay, babe. So let's go for the beginning part again. Chemical calculations. Okay, listen careful, everyone. If you have anything in your mind, just clear your head and then focus to the class. I want you to have your full attention here. People, atomic mass in it. Now, scientists were like, they wanted to create a constant thing. They want to create a constant thing which has a mass. It's like, 1/12 the mass of the carbon 12 isotope. That's a fixed unit. Let's just, so I don't have that. You don't have the tute because probably like I courier the tutes for the class students. So you don't want a tute. Actually, you can look at the screen and then follow the class. Sorry, I'm screen sharing it today. You can look and understand it. Sorry, you don't want the tute. Just I'm going to do a small session, very small session around like 1 hour. Just hold on, just to give you a short idea on the unit 3 and the beginning parts of it. Let's do it quickly. Table atomic mass unit is defined as the mass of 1/12 the mass of C612 isotope. Now, carbon 612 atom there, people. Carbon 612 atom. This carbon 612, are there other carbon atoms? Of course there is. There's carbon 13. There's carbon 13, and of course carbon 14 used in carbon dating and stuff. This is an isotope which is very rare. This is like 3%, and this is around 90. 98% or something. 98% or something you have carbon 612 in a carbon sample. So this is the majority. This is the majority amount of carbon they are in the atmosphere and everywhere. Now people may this equation, the atomic mass unit will be equal to 1/12 the mass of carbon 612 isotope. Okay. That's the first part. Atomic mass unit. Now you might think these are not much important. Yes, you are correct. Mole ටික එහෙම තමයි, like relative atomic mass, relative molecular mass, relative formula mass. I'm just giving you the basic idea of it. And then this introduction to mole concept is the important part which you're going to look at. Let's go through these parts. Now, relative atomic mass. What is relative atomic mass? To calculate relative atomic mass of an atom or ion, we divide its mass by the atomic mass in it. Now, people, we have calculated the atomic mass in it. Ne? Now, what we do is to calculate relative atomic mass. Relative atomic mass කියන්නේ now මෙහෙමයි. Like this. Let's see. Okay, look here. Now people, listen. There is a student called Alan. There's a student called Alan. Now this person is like the carbon 612 isotope. This person is like the carbon 612 isotope. Everyone's mass is with respect to this Alan. Alan's mass is 50 kilograms. Alan's mass is 50 kilograms. And if you have another person who is like, let's say, Peter, whatever, Peter. So Peter's mass is 100, okay, 100 kilograms. That's too much. Okay, let's increase the size. Nice. So that is 100 kilograms. So you calculated this and you kept me. You calculated that and you kept. Now we have to calculate the relative mass of this Peter. People, relative mass of Peter is equal to what? Mass of Peter divided by 1/12 the mass of Alan. හරිද? ඒ කියන්නේ the atomic mass unit නැත්නම් මම කියනවා Alan mass unit හරි මොකක් කියලා එකක් කියනවා, right? Mass of Alan. This is what you're going to learn under relative atomic mass. This is the equation actually. So mass of something with respect to another one. Now, why do we use this? Why can't we just say 100 kilograms? Why are we calculating a relative value? What's the use of this? People, atoms are very small. Atoms are very small. The mass of an atom is like 110 to the power minus 30 kilograms. 110 to the power minus 27 grams. A very small value, people. This small value we can't always put in periodic tables. Now here periodic table you are talking about a mass number, right? There we can't put 110 to the power minus 30 and every time we can't talk in these values. So because of that, in order to make things easier, we go for something like this, relative atomic mass. Relative atomic mass is easy, people. So when you calculate the relative atomic mass of oxygen, you get 16. Right? You calculate the relative atomic mass of phosphorus, you get 31. So something like that. It's just a relative value with another element and it's a whole number most of the time. Some decimal places will come, but we take an assumption, like we round off to the whole number and we take it. Hydrogen is 1, helium is 4, lithium is 7, and then beryllium is 9. Likewise, there are different relative atomic masses of different elements which are like whole numbers. So it's easier for us rather than telling these very hard values. We take something easier. Now let's go back to the tune. To calculate the relative atomic mass of an atom, we divide its mass by the atomic mass in it. Now, atomic mass in it is 1/12 the mass of C612, so you can write it that way also. Relative atomic mass. Relative atomic mass is what? Mass of atom which you are going to find just like Peter, divided by atomic mass unit. People, relative atomic mass is same as the mass number. The value is very like it's exactly the same value of a certain element in the periodic table. You have to keep that one also in your mind. The thing is, relative atomic mass does not have a unit, but mass number has a unit which is in grams. We're going to talk that later. The next one, people, relative molecular mass. Now, this is relative atomic mass and this is relative molecular mass. So, this is the mass of the molecule divided by the atomic mass in it. Easy, Hari. Relative molecular mass. Very basic concepts. These things you learn when you just come into A levels. Mass of molecule divided by atomic mass unit. Okay, my letters are ugly, people, don't worry. We can add the relative atomic masses of each element to obtain the relative molecular mass. We can do that actually. We can, if we add the relative atomic mass of each element, we can get the relative molecular mass. For example, H2O. People, H2O, relative molecular mass of H2O will be 1 plus 1 plus 16. Now, these values we obtain by calculating relative atomic mass. These are relative atomic mass of oxygen. This is relative atomic mass of hydrogen. This is the other hydrogen. So there's two hydrogen and one oxygen. So when you add them up together, you have how much? 18. Right? 18. Relative, so it doesn't have a unit. Then what else do we have? Like, ammonia, like 14 plus 3, 17, and CO2. CO2 is like 12 plus 16 plus 16. Very basic concepts. Okay. Okay. Now the next topic, relative formula mass. Relative formula mass it's same like molecular mass. I want to ask you a question. Now, this is a molecule, of course, H2O molecule. But do we call this one a molecule? Your answers, yes or no. Do we call NaCl a molecule? Sodium chloride molecule? Do you hear that? Tell me. Do you hear sodium chloride molecule? Drop me a message. Tell me, come on, don't be shy. Ravela, bavela. People, talk. Talk, 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 talk. No, you don't call it that way. People, these are not molecules, right? It's like, you can't tell it molecules. So, we tell another thing. We can't call them relative molecular mass because they are not molecules. They are ionic structures. So, we call it, relative formula mass. In the tutor also given. Can we call sodium chloride a molecule? No, that's wrong. It's an ionic compound. So, we don't call it molecular mass. We call it formula mass. Easy. Relative formula mass is equal to mass of ionic compound mass of ionic compound divided by atomic mass in it. Very basic calculations, people. You have some few calculations here. You can do them. Hari, you can do that as homework. Very basic calculations. I won't expect these kind of calculations in your A-level paper, but just for, to like understand these theory parts, I gave some questions here. Do this as homework, everyone. In the revision class, especially, we are going to discuss this in the next class. Now let's go for the mole concept. Listen, people. Now this is very important. What I'm going to tell right now in this next 15 minutes will be very important. So please listen carefully. Then balanna, we give a name for the number 12, isn't it? What is it? Dozen. We call it dozen. In chemistry, you call this number 6.02210 to the power 23 amount. You call that as 1 mole. Yeah, you can call it 1 mole of chocolates. That's fine. Like you have 6.02210 to the 23 amount of chocolates. Fine. That works. Mole is just a number. Mole is just a number. Right? Mole is just a number. One mole of whatever. Whatever the thing. Right? 6.02 to 10 to the 23 amount of something. Right? So that is what you use in chemistry. That is what you use in chemistry. The mole consider again this much amount of atoms. This much amount of atoms you call one mole. For example, one mole of O2. That means there is like 6.022 to 10 to the power 23 molecules of O2. Right? That's it. Now listen carefully. Mole is defined as a collection of 6.02 to 10 to the power 23 amount of atoms. Now this not always atoms, it can be molecules, it can be compounds, whatever it is, can be anything. One mole of O2 contains 6.02 to 10 to the 23 amount of O2 molecules. We can build the relationship for the above connection like this. If I tell N equals Ln. Do not memorize equations. I repeat, do not memorize equations. Just take it from logic. Just listen to me, okay? N is equal to Ln. People, this equation tells you a lot. Listen, what is this L value represent? What is this L value? People, L කියන්නේ Avogadro's number. Avogadro's number කිව්වහම you might be thinking like 0.77 1 2 3 4 5 6 1 2 3 4 5 6 වගේ homework හරි ගත්තා හිතෙන්නේ හරි Avogadro's number again not Avogadro's phone number or anything හරි it's the number which I told like 6.02 to 10 to the power 23 that's the Avogadro's number hurry. It's not working, people. I called one day and it doesn't work. Hurry. Like you can search Google for the rest of the numbers and you can call and see Avogadro, but that kind of number is not there. Avogadro's number. What is the Avogadro's number? 6.02 to 10 to the power 23. Does it have a unit? Of course, it has a unit. What's the unit? Per mole. 6.022 10 to the power 23 per mole. Do not forget per mole කියලා unit එකක් තියෙනවා ඒ number එකට. හරි per mole කියන්නේ මොකද්ද? In one mole වගේ නිකන් like per mole. 6.022 10 to the 23 amount of atoms in one mole per mole. Okay? English. What is simple N? Simple N is the number of moles of something. Number of moles. And capital N is going to be whatever total amount. For example, if I tell you how many molecules of O2 there are in 5 moles of O2. Again, how many molecules of O2 are there in 5 moles of O2? In order to calculate the number of molecules of O2 using the moles, what you do? You apply the equation, right? No, don't apply equation. That is only for beginner. That is only for 2027 students. Sorry, you don't apply equations. You're 2026 revision students. You don't apply equations. In especially chemical calculations, you don't apply equations. Of course, you have to apply equations in PV equivalent. They will give marks. But what I mean is, you don't apply equations in Unit 3. Not in inorganic essay question. You don't write equations and be like a very small child. Don't be like that. No, you don't write equations. What you do instead, you write sentences. Complete sentences. In a chemical calculation question, people, in order to get everything correct, again, like, have a perfect idea on what you are doing, first thing is diagram. You have to draw diagram. Diagram can have an understanding. Okay, what's going on? What's going on? Read it and draw diagram. What's going on? Second one, write sentences. Write sentences. Mass of barium sulfate. Write it. And then if they have given a value, then write it. 140 grams. Next line, write number of moles of barium sulfate in 15 cubic centimeters or whatever it is. මෙන්න මෙහෙම learn to write sentences. Because if you calculate the number of moles of barium sulfate in 15 cubic centimeters by some, you divide by the molar mass, 244 grams per mole, and you calculate a value, let's say, like just assuming 0.5, assuming, okay, not the real value, 0.5 moles, you have to calculate the number of moles of barium sulfate Not in 15, but in 100 cubic centimeters. And then you multiply this by 4. That is how you have clarity in your, your chemical calculation question. That is how you have clarity. Write sentences. Don't just do it like, don't write it like math students. For example, like if you check their book, people, math student කෙනෙක් පොතක් කරන් බලන්න. A boy, okay, check a student, මේ student කෙනෙක් පොතක් කරන් බලන්න math book එක. Their notebook is like, අර සීගිරී තියන්නේ මේ කුරුටු ගීත අන්න ඒ වගේ හරිද මේ don't write like that in chemistry මේ you have to have some clarity when you're writing like especially boys learn to maintain clarity during your inorganic part B නැත්නම් අපි කියනවා මේ chemical calculation question ඒක අපි පස්සේ බලමුකෝ we have not even studied the theory I'm talking about question writing okay I just told because you're revision students some of you might take a use from it. Okay, people, you don't write equations for this. What you do? Number of molecules of O2. That's it. Hurry. You don't write equations, you just write the value. 6.022 10 to the power 23 per mole multiplied by 5 moles. Easy, right? I don't want to do calculations from this, so easy. You get an answer, and that's the number of molecules of O2. Hurry. That's the number of molecules of O2. So capital N means number of total number. Hurry. Total number. Atoms I can tell it as atoms, molecules, ions, whatever it is. Total number of something. Even can be chocolate. It can be chocolate, right? I mean, like if you apply this equation to chocolate, of course you can get. If you say like how many chocolates are there in 5 moles of chocolate you would there, then you can multiply by the Avogadro's number and calculate. Very basic concept. Okay. Total number of something. Total number of something. Okay. Now, important thing again. Now, listen. Okay. Now, what have I discussed until now? We are like 20 minutes into the session now. I'm going to revise what we have done until now. Here we discussed atomic mass unit. What is atomic mass unit? It's the 1/12 the mass of carbon 612 isotope. We discussed it. And relative atomic mass. Now, atomic mass unit is like the mass of what? Allen, right? Mass of Allen is that's a constant thing which we take. 1/12 the mass of Allen is going to be the atomic mass unit, right? And then the relative atomic mass, if you want to find the mass of Peter relative to atom, mean Allen, what you do? Mass of Peter divided by 1/12 the mass of Allen. That time you call it atomic mass unit. So then you go to relative molecular mass. Relative molecular mass is same like relative atomic mass. Only thing is you're considering molecule. And then we learned like, relative molecular mass can be calculated by adding the relative atomic masses of each other. Again, if nitrogen, hydrogen, 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 you get ammonia. Easy. Then relative formula mass. Relative formula mass is the mass of ionic compound. We can't say molecules for ions, so that's it. Like wrong. So mass of the ionic compound divided by atomic mass unit, you have the relative formula mass. Then you have 3 calculation questions. You can do it as homework. Then the topic we discussed, introduction to mole concept. I told you what is a mole and the equation, like to connect the number of molecules together with moles. Who erased this part? Erase the okay. Right. People, now listen. Now listen. I'll ask you a question, not a chemical calculation question, but a normal logical question. If one person have 3 toffees, how many toffees does 10 people have? හරිද මේකට උත්තර දුන්නේ නැත්නම් කෙලින්ම I think හරිද 30 නේ හරිද 30 is the answer. Okay, 30 is the answer. Right, the 30 is the answer, of course. Hurry. Now I'm going to ask you another question. There are 84 eyes. There are 84 eyes. Again, like one person have two eyes. There are 84 eyes in a group of people. In a group of people, there are 84 eyes. Low. I want you to calculate how many people are there. How many people? Of course, 42. Easy. 42. Next question. Next question. There are there are um 3 moles of humans. Can be 3 moles of humans. My first Roman number is calculate the moles of ice. What is it? Calculate the moles of ice. There are 3 moles of humans. No, I want you to calculate the moles of ice. You can ask in moles. How many moles of ice are there? Huh? Tell me. Not chemical calculations, just logic. Okay? Tell me, tell me. People, people. Are you there? Go. Talk, talk, talk. How many moles of ice are there? One person have two ice if you don't know that. Okay? A coma? Kianda, tell me. Only one person is answering the questions. 6 moles. Easy, right? Again, people, one human has two eyes. Ne? Haru? One human has two eyes. One human has two eyes. So there's a ratio. What's the ratio? Humans to eyes ratio. Humans to eyes ratio 1:2. People, you know the number of moles of humans. What's the number of moles of humans? 3 moles. If they ask you to calculate the number of moles of ice, what you do? You consider this ratio. You multiply it by 2 because 1:2. 1:2. Right? So number of moles of ice will be 2 into 3 moles. Very easy concept. The ratios. Everyone know this ratios thing you have learned in, O levels. And, like basic logic, 6 moles of ice are there. That's not what I want to tell you. Not about ice. Look at this molecule, calcium carbonate. People, they are going to tell you there is, 5 moles of calcium carbonate. Then calculate moles of oxygen, moles of calcium. Calcium carbonate is not suitable neither. Okay, fine, whatever. Moles of carbon. Right? How are you going to do it? Just like the human theory. I told you there are how many? 3 moles of humans. Now what you do, they ask in the moles of ice. One person have two ice. So therefore you multiply by 2. This one, calcium carbonate, 5 moles of calcium carbonate is there and you have to calculate the number of moles of oxygen. So you multiply that by 3. Easy. 5 multiplied by 3, 15 moles. Again, moles of oxygen in the molecule because like one calcium carbonate contain 3 oxygens, just like one person have two ice, calcium carbonate contain 3 may oxygen atoms. So you can tell moles of oxygen will be how much? 15 moles. Moles of calcium will be the same 5 moles because one calcium is there inside. And moles of carbon will be 5 moles. So this concept I want you to understand. Right? This concept I want you to understand. Look at the diode. If we take this one step further, considering calcium carbonate, if 2 moles of calcium carbonate is present, calculate the moles of calcium, carbon, and oxygen in it. Easy. Let's see. Number of moles of calcium, that's going to be the same, right? 2 moles. Number of moles of carbon, same, 2 moles. Number of moles of oxygen, you multiply that by 3. 6 moles. You understood, right? Basic concept, very easy concept. Until now, what we have discussed right now is like, very easy. Now do the following exercise. First one, calculate the number of atoms in 1 mole of glucose. Okay, how many atoms are there in 1 mole of glucose? Again, total atoms I'm talking about, okay? Like totally full amount of atoms. How are you going to calculate it? Like, from what I taught you. How are you going to calculate it? Take 1 minute and calculate this quickly. Take 1 minute and calculate this. Okay, listen. Calculate the number of atoms in 1 mole of glucose. Well, first of all, we have to calculate the number of moles of atoms. That's what you're going to calculate. Again, total moles of each atom we have to calculate. Now there are how many? There is 6, 12, and 6. Altogether, how much? There is 24, right? There's 24. So 24 multiplied by 1 mole. That's going to be how much? 24 moles. So total amount of atoms in this sample is 24 moles. Now what do you do? Number of atoms in 1 mole is equal to how much? 24 moles multiplied by 6.022 10 to the power 23 per mole. Hari? Per mole. One more thing, may class in my revision class, there are 2 students who came from edexcel. Hari? Those people may calculators they have been using for a long amount of time, and then now when they shift to our prestigious A levels, what happens is they can't use calculators anymore and they are stuck. They can't do like simple calculation, they can't do without a calculator. Why is that? And why we are not using calculators? That's the problem now. Like, we are using something called, an advanced technological method in Sri Lanka, which is the logbook. You call it the logarithm table. Harik, this was used in people made, 18th century maybe. 18th, 19th century we've been using this thing. People main logarithm table like amaru hinda තමයි we created the abacus and like the supercomputers. Like currently there is AI also. Hari, we are still using the log table for A levels. I don't know why do they do that, but this is like I don't want to even talk about it. I hope they are going to change this after the educational reformation, which is coming quickly. May the thing is now there is nothing to like shout and wait. Karanda the you will have to avoid a calculator in your exam. You can't have calculators in A level chemistry, physics, maths. In other subjects you can have like commerce and all. May they have calculators? I don't know why, but they have calculators. But in calculations, ගොඩක්ම ඕනේ subjects වලට you don't have calculators. Like physics, chemistry, we don't have calculators. They don't give it. We have to use the logbook. Just like 18th century මේ Isaac Newton කාලේ වගේ we are going to use the logbook. හරි? Now the thing is you have to get used to it. You have to like avoid the calculator right now and then do the calculations with the pen and paper. Just like grade 2. You have to do it with a pen and paper. Start doing them because it's going to be a big mess if you don't do it. And just throw away the calculator and don't use a calculator. That's what I want to tell. Don't use a calculator. Use some shortcuts and like paper class again, then discussions, paper class discussions and homework questions, revision questions, and everything. When you're doing, just focus and listen on them, and then check how I'm going to simplify, and then apply that to your calculations. That's the easiest way. 24 into 6.022. People, now we have to simplify this. Uh, then make among calculators use growth. Only people among I'm not going to use a calculator here. Hurry. Then make a කරන්න මෙහෙමයි. Now this is a very small value people 6.022 it's a very small value. So make ignore කරන්නත් බෑ. I can't ignore it also, right? I can't ignore it. What I'm going to do is the multiply කරන්න වෙනවා. Use the multiplication. 6.022 into 24, 4 into 2, 8, 4 into 2, 8, 0, 6 into 4, 24, 2 into 2, 4, 2 into 2, 4, 0, 6 into 2, 12, and then 8, 12, 1 remaining, 5, 4, 4, 1. That's it. That's how you do. In Sri Lanka, that's how we do at A levels. 144.528. 5 to 8, 10 to the power 23. Per mole and mole cancel off, you can see that. So the number of molecules doesn't have a unit. So 1.445, 10 to the power 25. That's it. And easy, easy. And then next now, second one, calculate the moles of aluminium in 4 moles of Al2O3. I'll do it quickly. Everyone in the meeting should answer. Okay, now only few people have been answering. So everyone in the meeting should be answering the questions. I'll give you 1 minute. Good. Others? Everyone answer? Vaishnavi and everyone, Sanduni and Sendini, Nishwa, Oneli, Sayuni, Vishmi, Hashima, Fatima, whatever, everyone. Answer. How did the earlier question come to 10 to the power 25? Why I took 2 decimal places backwards? Scientific notation. I wrote it in scientific notation. 1.2 10 to the power 25. Tulasika, they're asking the moles, not the molecules. Okay, let's do it. Calculate the moles of aluminium in 4 moles of Al2O3. Now, people, let's write an equation again. A ratio. Number of moles of aluminium is to number of moles of Al2O3. Now, this is how you write in exams. These ratios, whatever, like even in an equation, you write an equation, let's say, like, ammonia plus oxygen goes to NO plus H2O. May equation එක ගන්නකො. හරි මේක ගන්නකො. In this example, people, if you want to connect two things, what you have to do first thing is write the ratio. Number of moles of ammonia is to number of moles of NO. If it is like that's equally number of moles of O2 කියමුකෝ. So the ratio is 4 is to 5. 4 is to 5. Make a like, get used to this. Get used to this always. So the ratio here, 2 is to 1, right? 2 is to 1. Now you can calculate the number of moles of aluminium by, multiplying it by 2. So 4 multiplied by 2 is equal to 8 moles, right? 4 moles of Al2O3. You just have to calculate the number of moles of aluminium. That's 8 moles twice, right? Let's calculate the number of moles of oxygen in this. Number of moles of oxygen is 3 times. 4 into 3. Easy. 12. තාම මේ ළමයි this is this is a very basic part. තාම ආවේ නෑ හරියද? තාම ආවේ නෑ. මේ අන්තිම හරියට යද්දි තරු පේනවා හරියද? මේවා එහෙම you know these are like the best level you can go in questions. At the end you have here නේ මේවා එහෙම කරන්න තියෙනවා. තව ගොඩාක් තියෙනවා කරන්න. There are a lot of things to do and extra sheets also you have to do. මේ ටික ඉතින් මං ස්පෙෂල් මේ කියන්නේ මේ වගේ සෙෂන් එකක් I took in order to explain these basic parts. We can skip it in the main class method. So if I do it in this way, you're going to learn it also, and then we can skip that part and do it from the important part. Actually we are not skipping it, we are doing it, right? Pure sample of PCl5 contains 10 moles of chlorine. Calculate the moles of PCl5 in it. Do it. Do it, do it, do it. A pure sample of PCl5 contains 10 moles of chlorine. Calculate the moles of PCl5. 2 moles. Easy, ne? So number of moles of PCl5 is to number of moles of Cl, 1:5. You know the ratio now. Number of moles of PCl5 will be 1/5. What you do is, people, you take this here, honey. Think like that. Take this number and put it at the bottom. Take that number and put it at the bottom. That's what you do. Even if this is like 2:3 or whatever, just take this number and put it here. Right? You know what to do. Take that number and put it there. When you do examples, you'll understand. 1/5 into 10. That's going to be 2 moles. That's going to be 2. Easy, yeah? Easy. Okay. In the above now moles and molar mass. In the above calculations, you found the moles of different elements and compounds. Of course, you calculated the moles of different elements and compounds. Did you ever wonder? Did you ever wonder what's the mass of 1 mole of that compound? Did you ever ask yourself, what is the mass of 6 moles of oxygen? What is the mass of, the main questions karaddi. What is the mass of AgCl? What is the, mass of Al2O3, whatever. You didn't worry about the mass, right? Well, now we have to worry. The mass of 1 mole of a compound is known as the molar mass of that compound. What is the connection between molar mass and number of moles? And we have an equation for that. Number of moles is equal to mass over molar mass. This is capital M. And what you have on top is simple M. So M is mass. And capital M is going to be molar mass. And N is the number of moles. Molar mass what is molar mass? Molar mass the mass of 1 mole of something, you call that the molar mass. Molar mass of chocolate, what is that? Mass of 6.02 to 10 to the 23 amount of chocolates. Molar mass of oxygen, that is 6.02 to 10 to the 23 amount of oxygen at its mass. That's it. Number of moles is N. So this is the connection in between, mass, molar mass, and number of moles. Now we have some questions, easy questions here also. They might look complex, but they are not complex. Look at the first question. A sample of iron 3 oxide, Fe2O3, has a mass of 12.8 grams. Calculate the moles present in it. They have given the molar mass. Easy question. Let's go through it. I'm going to do it here. Look, I'm going to do it here. People, now they have given the mass. They have given the mass. Molecular mass and molar mass is the same. Molecular mass. Yes, you can tell it, but it's not always true because sodium chloride and all they are not molecules. Ne? Molecular mass can molar mass is mass of one mole of compound. Molecular mass is mass of a molecule. That's different. I think. Different. You can't tell they are same. Molecular mass is like different than molar mass. Molar mass is mass of one mole of compound. Molecular mass may be mass of a molecule. That may be very small value. They are different. Moles of Fe2O3. Fe2O3. Don't write equations. Don't write this equation. Just because I gave it, don't write. Right? Don't be, very small children. Moles of Fe2O3, or you can write in a more advanced way like this. Number of moles of Fe2O3 is equal to. Number of moles of Fe2O3 is equal to mass of molar mass, 12.8 grams divided by 160 grams per mole. 160 grams per mole. දැන් මේක සිම්ප්ලිෆයි කරන්න එකනේ අවුල. ඔය කට්ටියට තියෙන්නේ මේක සිම්ප්ලිෆයි කරන්න එකේ අවුල. මම නම් කියන්නේ take a rough worksheet 12.8 divided by 160. දැන් මාත් ගොඩක් කාලෙකින් I haven't used logbooks and everything. මම මාත් ඉතින් calculators තමයි use කරන්නේ. මම ඉතින් logbook පාවිච්චි කරන්න මට පිස්සු නෑනේ හරිද? But you have to know how to use a logbook and all. I'll teach you. I'll put a separate video on how to use the logbook. Free for everyone because it's important for like units, pH and all. It's important. What was it? 12.8 divided by 160, right? My people. This zero, this zero you can consider it as a 10. So 12.8 divided by 16 into 10 kilogram. Because when you divide by 10, what will happen? It will go decimal point backwards, right? Decimal point at so it will be 1.28 divided by 16. Right. Now you can see this can be divided by 2. If you divide by 2, this will be 8. This will be 0.64. You can again divide by 2, right? 0.32. You can again divide by 4. You can divide by 4, 0.08. That's it. 0.08. Simplify and go until you get an answer. That's what you do. 0.08. That's the answer. 0.08 moles. That's it. So that's the number of moles of Fe2O3. Easy question. Make it again. I won't tell them this is hard. Second one. 7.5 grams of calcium nitrate is taken. Calculate the number of moles. Do it on your own. Do it on your own. Mass. What a mass. ඒකේ simplify කරන්න අර මහා ලොකු ඉතින් විදිහ there's no method කියලා එහෙම එකක් නැහැ ඉතින් like simplify and see 7.5 divided by 164 දැන් බලන්න 7.5 divided by 164 you can't divide by 2 right you can't divide by 2 so what you're going to do is divide by 164 if you can do it inside your head then good it's like 0.0 then 164 into 750 වලට ගියක් යනවනේ 1 2 3 4 around 4 වගේනේ 0.04 something right 0.04 something only you will get so multiplied by 4 is 0.416 1 remaining 64 24 25 2 remaining 0.1456 656 අනේ 5 දෙන්නේ අනේ 4 නේද 444 0.04 and then 750 minus 656 that's going to be how much 94 there 94 වලට බලන්න 94 වලට 164 ඒවා it's going to be again මේකට බිඳුවක් දැම්මහම 164 into maybe around 5 maybe around 5 6 වගේ maybe around 6 0.046 වගේ එනවා right 0.046 වගේ එනවා let's look at the calculator and see 7.5 divided by 164 0.0457. 0.0457 can when you round off, you get 0.046. So that's the answer. 0.046. නැත්තම් 0.57 කියලා දාන්නත් පුළුවන්. That also possible. Okay, paper. Then third one. What mass of magnesium will contain 0.75 moles of atoms? What mass of magnesium contains 0.75 moles of atoms? So they have given the moles. What you have to do is mass of magnesium is equal to, don't write equations again, 0.75 moles multiplied by 24 grams per mole. බලන්න මේ equation ලියන්න ඕනෙත් නෑ people, like moles and per moles cancel, you get grams, that's what you want. So 24 multiplied by 75. මේකට ඉතින් use කරන්න මේක 75 වලින් multiply කරන්න. 5 into 4 20, 2 remaining, 5 into 2 මේක automatically ආවන. I don't want it automatically. 5 into 4 20, 2 remaining, 5 into 2 10, 11 12, 7 into 4 28, 2 remaining, 7 into 14 15 16, 0 8 10 1 6 7 8 and 1. That is going to be 18, right? 18 grams. 18 grams. Fourth one, how many moles are present in 3.2 grams of sulfur dioxide? ඒකත් ඉතින් අර වගේ තමයි. Number of moles of SO2. Number of moles of SO2 is equal to mass or molar mass. 3.2 grams divided by molar mass of SO2. Now molar mass of SO2, 16 and 16, 32, 32 and 32, 64. 64 grams per mole. Now you divide 0.05. ඒක ඉතින් අර practice එකත් එක්ක තමයි නේ. Like have the practice. 0.05. Even I make mistakes. Everyone will make mistakes. It's fine, anything, right? Simplification errors and all. 0.05 moles. Fifth one, a hydrate of copper sulfate has a molar mass of 250 grams per mole. How many moles are present? Same thing. I won't do this. It's the same thing, people, mass or molar mass. Then next one, sixth one. Calculate the mass of one atom of chlorine. That's interesting. Calculate the mass of one atom of chlorine. The molar mass can what is molar mass? You need to know the definition of molar mass now. Mass of 1 mole of chlorine, right? That is 35.5 grams. Huh? Right? Mass of 1 mole of chlorine will be 35.5. They're asking mass of one atom. So what do you do? What do? You divide by what? You divide by what? Avogadro's number. Why? People, molar mass කියන්නේ mass of 6.022 10 to the power 23. Mass of 6.022 10 to the power 23 amount of atoms. That's going to be the molar mass, which is 55. 35.5. 35.5. 35.5 grams is the mass of, 6.022 10 to the 23 amount. They're asking mass of one atom. Mass of one atom. Mass of one atom. Can you divide this? 35.5 divided by 6.022 10 to the power 23. And you get an answer. That's going to be the answer. Grams. You are going to get an answer in grams. Determine the mass of one molecule of ethanol. It's the same thing, people. Molar mass of ethanol divided by 6.022 10 to the 23. Easy. Eighth one, the molecule of aluminium oxide contains 2 aluminium atoms and 3 oxygen atoms. Calculate the mass of one molecule. Okay, do it. You can do it. Do it. I'll give you, that's a little bit different question. Few minutes I'll give. Maybe 1 minute. 1 minute enough. Okay, now we have a molecule of aluminium oxide contains two aluminium atoms and three oxygen atoms. Calculate the mass of one molecule. Mass of one molecule හොයන්න කලින් people we have to calculate mass of one mole. Yani molar mass. Molar mass නේ mass of one mole, that's the molar mass. So aluminium is 27, 27 into 2 plus 16 into 3. 27 into 2 how much? 25, 25, 50, 52 and 54. 54 plus 16 into 3, 6 into 3, 18, 1 remaining, 3 into 1, 3 plus 1, 4. 48 and 54, that's 52 and 102 grams per mole. That's the mass of, you know, one mole of compound. So what you do? You divide this by 6.022, 10 to the power 23 per mole. Per mole cancel off. Then you get an answer. That's going to be the answer here. 102 divided by 6.022. Ninth one, find the mass of 10 to the power molecules of carbon monoxide. Calculate the mass of 10 to the 5 molecules of carbon monoxide. So there what you should do. First of all, you calculate the mass of one molecule. Just like, the seventh question. Calculate the mass of one molecule and then multiply it by 10 to the power 5. I shouldn't do these things so easy. 10th one banana. Molecule of glucose contains 24 atoms. Calculate the mass of one glucose molecule. It's the same method just like the eighth one. Just like the eighth one, same method. These are beginners questions, people at the beginning of the tute. So, it's the same thing. Mass of one glucose molecule. With a molecule of glucose. So 24 atoms. Calculate the mass of one glucose molecule. Easy. So you multiply, you calculate the molar mass actually. They have given it. So it's more easier now. So you divide by what? 6.022 10 to the power 23. People, did you understand this part? Stoichiometry and all, let's do in the next class. Now only from stoichiometry only you have decent questions, people. Otherwise it's just, baby questions you have from these parts. Stoichiometry and all we are going to discuss now next week. Friday night, the class we are going to put it on Thursday night. Again, for a fixed time. Now, Monday night is fixed. Monday night 7 p.m. is fixed. And before I told you it's on Friday night, but I will have to put it to Thursday night because I know Friday I have certain thing to do, like another class which cannot be shifted. Therefore, I thought of like putting the revision to Thursday. Thursday night. Thursday night කියන්නේ 7 p.m. onwards we have an extra class for the week. Otherwise, we won't be able to complete the syllabus. And also, people, midnight accelerators, we are going to be focusing on small theory parts and trying to complete them. Tomorrow night, tomorrow night you have, of course. Tomorrow night you have the class. Monkey anime next week. This I'm talking about the next week. Tomorrow class we have. Tomorrow night class you have. Tomorrow night you are going to do periodic variations. It's for the revision students. And it's not a free session. We did a free session on Monday and today is a free session. So a lot of free sessions will come, of course, but not everything. Right. Then people, you can leave the meeting. We can now continue from stoichiometry onwards in the next class. Good night. And, in midnight accelerators, we'll be doing these kind of short theory parts, especially periodic variations and all next week. We'll focus them. more. And the question discussion of Midnight Accelerator will be put as a recording. Don't worry, within the next few days, I'll put it. Good night.